All right, cool. So last week I left all with this dilemma. It was a problem. Yeah. Because we don't know what x is that will satisfy this particular equation. And we can't bring everything to the same base to solve the equation. To reach that line, bases are the same, equate powers. And we talk a little bit about logs. And we say that how logs, they are operations, just like trigs are operations that we perform on a number to get another number. So I'll just have a small recap. Log of 10. I wouldn't do log of, I will do log of 10 because I fancy a little bit. Log of 10 is 1. It's a nice number. Log of 5, not a nice number. But when I have an input, I get an output, which is also a number. Log of 9 is this. Log of 5, 9, 8. Log of a whole big number is that. Log, I could have log of sine of a number. I get something, all right? And the next log that we have is ln. ln of 6, ln of 10, ln of 98. Everything will give me an output. Just as indices has laws, logs has laws. So we'll dive into the laws of logarithms. Now, logs is short for logarithms, right? But hardly you'll see logarithms appearing in questions. You'll see logs, right? Now, the first law of logs is very, very similar to the first law of indices. The second law is also very similar, but you need to distinguish between both of them. Before we distinguish between both of them, just how we learned how our indice looks or exponent looks, we need to learn how a law looks. We need to learn how a log looks. Now, a log comprises of a couple of components. Logs look like this. Log of A, B is equal to C. Now, B is called our base. A is a number. And C is also a number. And we read this a particular way. This, I will put equal sign. This is read as log of A to base B is equal to C. For example, if I have log 5, 2 is equal to 6. Just an example, all right? This mathematically is wrong, but just an example is read as log of 5 to base 2 is equal to 6. What about this one? Somebody give me some help. Log of 10, 6, 11. Somebody. Anyway. All right, Tristan, help me. How are you doing this?
Log of 6 to base. No, wait. Sorry. Log of 10 to base 6 is equal to 11.
Very good. Let me do one more. Kiran, you go help me with this one. How are you doing this, Kiran?
So log of A to base X is equal of base X equal to 3.
Very good. Everybody comfortable with that? Reading logs. Good. Sean, you again? Me MC Sean self. Okay, good. Your camouflage and Sean. All right, now let me go through the laws. Very, very simple laws, but very simple to make mistakes in the laws as well, especially law 1 and law 2, just like indices. Everything in indices depended on what? Well, not everything, but the main thing in indices we try to do or try to look for was what?
If they had the same basis.
Very good. Same basis. That is what we try to achieve, because literally everything in indices will always come back to law 1 and law 2, and then we will execute our calculations from there. Same thing with logs. Everything will come back to law 1 and law 2, which is like a foundation. So laws of logs. Law 1. Now, before, I had a worded explanation for each law. But for logs, I find it a bit tedious to have a worded explanation for each law. Instead, I will talk out the law and write down the law itself. So the law states that if we have log of a number, let's say the number is m, the base b, plus another number, log of n to the same base b, this is equal to log of m multiplied by n to base b. Now, the bases have to be the same for this law to work. Okay? Bases have to be the same. And the law works both ways. For example, if I have log of 3 to base 2 plus log of 7 to base 2, this is equal to log of 7 multiplied by 3 to base 2, which is log of 21 to base 2. All you agree with that? Another example, if I have log of 4 to base, let me say 9, plus log of 6 to base 9, this is equal to log of, and I'm not writing down the calculation, I'll just put 24 to base 9. Agreed? I'll do the reverse of the law in the same breath. This could be equal to log of 12 to base 9 plus log of 2 to base 9. You all agree with that? Because 24 could be broken up as 12 multiplied by 2. So I'm working in this direction of the law for this piece here. All right? I could work either way, forward or backward. Everybody comfortable with that so far? Yeah? Do right, Tristan. Pay attention. You'll get a chance to write just now. Don't worry though. Let me mash up law 2 one time. Now I'll do the laws next to each other to show you all how they are very, very similar. The next law states that if I have log of a number to the same base b minus log of a number to base b, what do you think this will be? Very, very similar to law 1 in logs and law 2 in indices.
So it'll be log b m divided by 2 n, sorry, m divided by n.
What base?
Log base
Base what?
b.
Very good. The base b. Everybody agrees with that? For example, if I have log, and I'll use nice numbers, log of 10 to base 3 minus log of 5 to base 3. This is log of 10 divided by 5 to base 3, which is log of 2 to base 3. Yeah? Log of 4 to base 10 minus log, let me put log of 20, I'm trying to be a little versatile here, 40 minus log of 5 to base 10. This is log of 40 divided by 5 is 8. Yeah? This could be expressed as log of 16 to base 10 minus log of 2 to base 10. Agreed? It could also be expressed as log of 4 to base 10 multiplied by log of 2 to base 10. Agreed? Because this here would be log of 8 to base 10. This is log of 8 to base 10. This is log of 8 to base 10. Everybody agrees on those properties so far. Yeah? All right. Now, there is a very, very common misconception and an easy mistake when performing laws 1 and law 2. I want somebody help my head, right? And it's okay for I want to let it get wrong then. I want to let it figure this out. If I were to use logs to simplify or to execute this question, if I have log of x plus y to base 6, what is this equal to? Or what looking like it equal to? Mikhail?
So x log base 6 the y. Oh,
Boy. Try again. I don't mind if I get wrong. Sean, you want to help him?
Well, that's where I trying to.
You're trying to try?
Yeah,
And you're trying.
exactly.
Justin?
So I think it's log of x to base 6 multiplied by log of y to base 6.
Log of x to base 6 multiplied by log of y to base 6.
Yeah.
It looks correct, and
Yeah.
this is the common mistake that I see plenty times, right? And I don't want Ola to make the mistake. Now, it looks correct. It looks like the correct thing to do based on the laws of logs. But we never learn a law that says if I have a log of a sum, I can break up that sum. I have log of a number plus log of another number. I don't have log of a number plus a number to execute a law using log of a number plus a number. You're seeing that? I'll show you an easy way to remember law 1 and law 2. On a calculator, there are 2 log functions. 2. log and ln. Those log functions on the calculator are set to a specific base already. log is equal to log to base 10, and it's abbreviated as LG. So when I press this on my calculator, bam, this is log to base 10. All right. On certain calculators, I can input a specific base, but on 99% of the calculators you all will use, log is log to base 10. Okay. Ln is log to a base e. Now, what is e? E is a number. And pi is a number. Pi is 3.14 going down the road. Yeah. E is also a number. It represents a constant. It represents an irrational constant, meaning it has an infinite number of decimal places. It just keeps going on and on and on and on and on. So these are the two log functions I have on my calculator. An easy way to remember log 1 and log 2 is write down the law, try to remember the law in terms of base 10. So for example, this is I'll rub this over after. This is strictly on how to remember the law. If I want to remember log of 4 by point base 10 plus log of 6 to base 10 plus. This supposed to be log of, what is that, 24 to base 10. Yeah? If I'm trying to remember the law, well, this is already log to base 10, so I don't have to bother entering a base. Log of 4 plus log of 6 is this number, 1.380211242. Cool? I expecting this to be the same number, so if I take it away, I suppose I get 0, correct? If it is the same number. I'll follow me there. If I take away log of 24, I suppose to get 0. I get 0, which means this is correct. So if I were to do the converse and I say, well, you know, we catering for the mistake now, log of 4 plus 6 to base 10, is this equal to log of 4 to base 10 multiplied by log of 6 to base 10? Is it equal? Let's check and see. Log of 4 plus 6 to base 10 is log of 10 to base 10, right? Which is 1. So I'm expecting this side to be 1 as well. If this is the law, log of 4 by log of 6 is not 1. So I know that this cannot be a law of logs. It doesn't follow a law of logs because the left side is not equal to the right side. This one is a law of logs because the left side is equal to the right side. It takes a little practice trying to remember the laws. It takes a little practice using this method to remember the laws. Okay? And that will come in time. It will come in time. Law 3. Everybody good with law 1 and law 2 so far? Law 3 states that if I have log of, which one, boy? Log of a number to the same base, this has a value of 1. For example, log of 2 to base 2 is 1. Log of 6 to base 6 is 1. Log of x to base x is also 1. Easy law, yeah? Just like law 4 in indices, yeah? Similar to law 4 in indices. And I use law 4 in indices to express 1 as any base. 1 is equal to 4 to the power 0, 6 to the power 0, a to the power 0. I can use law 3 to express 1 as any log. Law 4. Log of 1 to any base is equal to 0. For example, log of 1 to base 2, 0. Log of 16 to base, log of 1 to base x is 0. Log of 1 to base w is 0. Yeah? Okay, next color going on here, man. Law 5. Now, law 5 is one of those laws that is used extensively in equations. Law 5 states, if I have log of a number raised to a power, I don't care what the base is, the law says that this is called the power law. I can move the power in front. So this is C log of A to base B. For example, if I have log of 2 to the power of 4 to base x, this is 4 log of 2 to base x. If I have log of 3 to the power of x to base 6, this is x log of 3 to base 6. Are you following? Remember law 5? If I have log of 6, I want to give it a little 6 to the power of, let me go easy now. 6 to the power of 4 to base 2. This is 4 log of 6 to base 2. Cool? Good. Everybody good so far? Law 6. Now, law 6 is one of those laws that intertwines into indices. I can change a log to an indice, and I can change an indice to a log using law 6. So if your logs look a particular way, log of a number to a base is equal to a number, and indices look like a base to a power is equal to something, there's a relationship between the two. Now, law 6 is I'll say the most important one. Law 6 states that if I have log of A to base B is equal to C. We know this is how our log looks. Yeah, log of A to base B is equal to C. Yeah, generally, this is how our logarithm looks. I can convert this to an indice. This is equal to B to the power C is equal to A. This is the indice equivalent. Now, how to get that, boy? What we had to do to remember this? How are we going to execute this? We working in a counterclockwise direction to remember this law. This is how I remember the law, right? I'm changing it to indice. So I must start with base to power is equal to a number. That's how our indice looks. Base to power is equal to a number. Yeah? And we work in this direction. Base to power is equal to a number. All right, that's how I remember it. Easy way to remember it. For example, and now all of these examples I'm giving you is not mathematically correct. I am just illustrating the law, how it works. Okay? Log of 4 to base 10. Let me say that's equal to 3. Hypothetically, that is equal to 3. And I want to change this logarithm to an index. 10 is going to be my base to the power of 3 is equal to 4. That's how I am changing it to an index. Okay? Again, it's not mathematically correct. I'm just illustrating the law in action. Okay? Another example. If I want to express log of 11 to base W is equal to 4. I want to convert this to index. W to the power of 4 is equal to 11. All seen it? Now, I'm putting down this symbol here, and I should have been putting it down before, because logs work in both directions. Okay? They do work in both directions. So you'll see I'm putting on the equal sign with the 2 arrows on either end of the equal sign. That's because logs work in both directions. Okay? Please don't forget that. It works in both directions. Everybody good so far with the laws of logs? Easy laws, easy laws to execute. Fairly easy laws to remember. I want you all to take down the laws, and we're going to do some questions with it. All right, so tell me when to scroll down, and I'll scroll down, okay?
Reggie Rev's true. So actually on that one is Hal Jordan, Evan
Remember, tell me when to scroll down, okay? From the last. All right, cool. Now, I will, at the end of the recording, for those of you all who are watching it over, I will explain back these things, right? At the end of the recording. All right, so the first one, log of 3 minus log of 8. Simple as you see it. This is log of 3 divided by 8. Next one, log of 6 divided by 3. This remains as log of 6 divided by 3. You can't do this. That is incorrect too, right? Remember when we did trigs in maths, I told you all treat the angle as something very special, something very sacred, and don't touch the angle. Same thing applies to this number. Don't touch it on something that is not a log. This is not a log down here. But I can change it to a log if I wanted to. All right. 3 can be changed to a log. And we will leave that for something further down the road. If you all wanted, this is the exact same thing as 1/3 log of 6. All right. These two expressions are the same thing. And if you wanted, you could have said this is log of 6 to the power of 1/3 if you wanted. All right. Main thing I want you all to take away from number 14 is do not do this. Do not do that. Next, I do not have the same, I'll say I have the same base, but I want to have log of a number. So I'll send the 4 on top, I'll send the 4 on top, and then I will use log 2. So this is log of 3 to the power 4 minus log of 8 to the power 4, which is log of 3 to the power 4 divided by 8 to the power 4. If you wanted, this is also equal to log of 3 over 8 all to the power 4, and you can bring the 4 in front. 4 log of 3 over 8 if you wanted. Next, this is log of 2 by 11 by 7. Simple. You could work out what this is. 11 by 7 is 77. 77 by 2 is 154. So this is log of 154. This is log of 7 take away log of 12 to the power of 2, then log of 7 over 144. Next, this is log of 7 to the power 2 all over 3, which is log of 49 over 3. Again, don't cancel, please. And we in some territory where we start having some variables. So I'll do these questions on the side. Ascending the 6 as a power, log of u to the power 6 to base 3 plus log of v to the power of 6 to base 3. Oh, no. V to the power 6 to base 3, right? I was watching number 21. Which is log of u to the power 6, v to the power 6 to base 3. If you wanted, you could have said this is uv to the power 6, a kind of reverse law 5 from indices to base 3. And then you use law 5 from logs. 6 log of uv to the power of 3. Number 20. ln of x minus 4 ln of y. Remember I told you all ln is just log to base e. It's just an abbreviation for log to base e. That's it. All right. You will get accustomed using this abbreviation because it is convenient. So this is ln of x, take away ln of y to the power of 4. These bases are the same. ln and ln, they are the same base. So this is ln of x divided by y to the power of 4. You all get that? Again, if anyone has any questions, you need to let me know, right? Log of u to base 4 minus log of v, 6 log of v to base 4. I need to change both of them as log of a number. Log of u to base 4, take away log of v to the power 6 to base 4. And then I use law 2. Log of u divided by v to the power 6 to a base of 4. Number 22. Log of u to base 3 minus 5 log of v to base 3. Similar to number 21. Log of u to base 3, take away log of v to the power 5 to base 3. And then I use law 2. Log of u over v to the power 5 to base 3. Put this in a bracket now. Number 23. Similar to number 20, to number 19, this is 20 log of u to base 6 plus 5 log of v to base 6. This is log of u to the power 20 to base 6 plus log of v to the power 5 to base 6. And this is log of u to the power 20 over v to the power 5 to a base of 6. Yeah? Numero 24. Log of u to base 3, 4 log of u to base 3 minus 20 log of v to base 3. This is log of u to the power 4 to base 3, take away log of v to the power 3 to be, sorry.
Yes,
Yeah?
number 23 is product law.
Oh, shucks. My bad. U to the 20 multiplied by v to the 5. Sorry about that. Number 24 is minus, so this I just double checking. This is log of u to the power 4 divided by v to the power of 20 to base 3. Yeah? Why divide in number 20? Oh, okay, cool. So that answers your question, they just done. All right, so number 25, 25 and 26 is critical thinking exercises, right? Now, number 25, the first thing you should notice here, all the bases are the same. Yeah? Just like in indices, all of these bases are the same thing in this question, in this worksheet. All of the bases were the same thing. And Tristan asked a very good question. So will they ever have working with different bases in logs? And they will be working with different bases. We're going to reach that in the next class. How we tackle in different bases. But number 25, simple algebra. Expand the brackets and simplify. Number 25 will be 2 log of 2x. Take away 2 log of y. Take away log of 3 minus 2 log of 5. I will send all the numbers as powers. Be careful when you're sending the number as a power. This is log of the number to the power minus log of the number to the power minus log of 3 minus 2, well, minus log of 5 to the power of 2. Now, plenty minus signs going on here, correct? Plenty minus signs. So what we could do? Remember, I told you all there are two different ways to represent division. One way to represent division is using this 4 divided by 8 or 4 divided by 8. Yeah. It's log 3 plus this minus sign. When it distributes here, it changes the minus sign, the plus on this one here, Mackay. Yeah. So I'll use my long time division sign for this. As I see the laws in logs, I will execute the laws in logs. This is log, open bracket, 4x squared divided by y squared divided by 3 divided by 25. Now this could be simplified. And when we get a little stronger in algebra, then I'll show you all how to simplify this. All right. Number 26, log of x divided by log of 2 remains as log of x divided by log of 2. You can't simplify it. Right? You can't say this is log of x divided by 2. This is wrong. Okay? You cannot simplify this. Cool? Anybody have any questions? Now is it time to ask before we close off class?
So isn't number 26 multiplication?
Sorry. You can't do same concept applies, right? Log of x multiplied by log of 2. This is not log of 2x. Right? You cannot do that. Cool. This remains as is. Questions? All good? All right. If you'll have no questions, I will send another worksheet on the group for you to tackle for next class. It will be a little more challenging than this set here. And in the next class, this is what we're going to do. We're going to learn how to solve equations where the bases are not the same and I cannot bring the bases to be the same thing. And we are going to learn how to deal with different bases in logs. So the next class, we will be 75 to 80% done with logs until we encounter it a little later down the road. All right. All right. So if you all have no questions, you all can go ahead. And I will see you guys next week, Monday.
Later, sir.
Later.
Later, sir.
Later, sir.
Later.
So,
Mm-hmm.
because I joined later, it had the recording I could get for this.
Yeah, just send me your email now on WhatsApp.
All right, cool. So thanks.
Yeah. All right. So as promised, guys, I will run through these questions now. All right. So number 1, straightforward. Straightforward law 1. Number 2, again, very, very straightforward. Number 3, I can do it a couple ways. One way I can do number 3 is by using law 5 and bringing the 5 in front. Or I can use my laws of indices and distribute the 5 on the 6 and the 5 on the 11. So the first way I did it, I brought the 5 in front, 5 log of 6 on 11, and then I used my logs law and I expanded 6 over 11 as log of 6 minus log of 11. Then I expanded the 5 on each of the terms in the bracket. Or I could have expanded, well, distributed the power on each of the terms inside of the bracket. I'll get log of 6 to the 5 over 11 to the 5, and then use laws of logs and simplify it using my law 2. Then I could have used law 5 and bring the 5s in front. Number 4. Number 4, a common mistake is students will bring this 3 in front of the entire log. But I do not have a log of an entire number raised to a power. Only the 2 is raised to the power. So I need to use law 1, separate them, and log of 2 to the power of 3. Remember, log as it stands is the base 10. So it's understood it's the base 10. So I didn't have to write back base 10 in the rest of them. I just did it for the first 2. Back to number 4. Log of 2 to the power 3. I can now use law 5 and bring the 3 in front. Number 5, same concept applies. Log of 2 to the power 4 over 5. I cannot bring the 4 in front. I have to separate this by using law 2. And then I will use law 5 to bring the 4 in front. Number 6, however, I can't bring the 6 in front because I have log of an entire number raised to a power. Or I could have distributed the 6 on the 6 and the 6 on the 5 and then use law 2. So either or. Number 7, same principle. So ask yourself, pause the video and ask yourself, which law will I use first? Will I use law 2 first or will I use law 5 first? For number 7, I have to use law 2 first because the 6 there is on the power of y alone. It's not on the power of x over y. So I'll separate them using law 2, then I'll use law 5 on the log of y to the power of 6. Ask yourself the same thing for number 8. Will I use law 1 or law 5 first? I cannot use law 1 first here because I do not have log of a number multiplied by another number. The power outside causes me some problems. I could either distribute the power using laws of indices, or I can bring the 2 in front using laws of logs. Number 9, ask yourself again, will I use law 5 first or will I use law 2 first? Well, I have to use law 2 first and then bring the 4 in front. Number 10, same thing. I'll use law 2 first. Number 11 is dependent on your knowledge of indices. You need to be very, very good with your laws of indices, especially law 7 that states if I have a fractional power, I'm dealing with some root. Over here, I'm dealing with a root of an entire something inside of the root. So I know I'm dealing with a fractional power if I were to change it to indices. So I can change the cube root to a power as 1/3. Then I use law 5, bring it in front, expand the x by y by z. Because of the lack of space, I didn't put 1/3 log x plus 1/3 log y plus 1/3 log z. Number 12, similar, but you have to be careful. I cannot put the 2 in front of the entire thing because the 2 is only on the power of z. If I had a power outside here, let's say the power outside here was 3, then I could have distributed the 3 in front. But for number 12, the first thing I have to do is use law 1, then I will use law 5 on the last term alone. Well, number 13 to 26, you'll have the recording of that already.